Thank you, Jerry. Our next speaker is Joe Salah from MIT. And Joe was Cedar Chair from 1997 to 1999. And so Joe has some retrospective viewpoints on Cedar.
Let me begin by thanking Jeff, Barbara, and the steering committee for inviting me to come back to Cedar and to participate in this nice celebration of the 25th anniversary. It's really a pleasure to be here. For me, after a 42-year career at MIT, I finally decided to retire last year. And I've been involved in many programs, many projects over the years, but Cedar has really a special soft spot in my heart. I think it's an ideal program, not only because the government gets a lot of bang for its from its buck in the investment that it makes into Cedar, but the collaborations are real. They're long enduring. They're truthful. They're honest, and it's a collaboration that I've valued over my entire career, working with the scientists, the students here, the sponsors. And it's really an ideal program, and I think we should all feel very good for all the friendships that have been formed during those 25 very important years. So I thank you for inviting me, and as a token of appreciation, I decided to put together a short talk, 3 short stories about Cedar, some of them in the early days, and they're lighthearted and more of an after-dinner type of enjoyment and entertainment rather than to be making any special political points. But so bear with me as we go through these. The first one I'm going to talk about is the background of the Cedar logo. Many of you probably don't know that background. It's you've seen the logo, but I'd like an opportunity to kind of remind you what it really means and where it's going in the future. I want to give you some personal recollections on the development of AMISR. These are very personal because I've seen all the pain that went into, after about 20 years, to get to the data that you see now from this beautiful instrument. And then I want to tell you about a singular Cedar Science success story, which probably is a very good model for other projects that are now developing their programs, their observations, their modeling. So let me start with the first one on the background of the Cedar logo. That's the logo. It was developed and I think accepted by the community in around 1987. Forgive me, some of the dates that I will show you may not be exactly right. But I remember participating in one of the first Cedar steering committees, and we were called to Ann Arbor by the then very young, ambitious chair at that time, from my recollections. He called us to Ann Arbor. You could tell the guy was going places, that he was going to rise up the chain. He was going to have very important responsibilities. And he tasked all of the members of the steering committee to come to Ann Arbor with their idea of a Cedar logo. He thought that was very important. It was a very high priority thing that will give an identity to the program, and that will help us secure the funds that were not that easy to secure at that time. And so this was sketched on the back of a US Air napkin on the flight from Boston to Michigan, and it ended up surviving 25 years. But it was a competition, so a lot of very good designs came up. They were dismissed early on through votes, very, very honest votes amongst the committee members. We got rid of the radar antenna. We thought that was too self-serving. We got rid of the LiDAR beam. We got rid of the Aurora because we thought that was too self-serving. And then there were two final ones left. The one that the chair that called us to Ann Arbor, and this one. I'll tell you about this one a little bit. It's an interesting one because it represents, of course, the Earth. It represents the different layers of the atmosphere, starting from the troposphere all the way up to the thermosphere and ionosphere. And of course, Cedar is the trunk of that tree, which gives you the coupling between these various layers. And that is really actually what the main focus of the program has been for the past 25 years. And we recognized, of course, that you can't do a study like this without having actually a global set of observations. You cannot do it only from one sector of the Earth. And as a result, so that was the first circle. The second circle involved really the international collaborations that were important as soon as you get into the global aspects of collecting and comparing data. And of course, all of these principles held very nicely. We do have a very good international program, and we're happy to have so many international collaborators to come to our meeting. Well, back to the story of the competition. The other candidate logo was one that showed a very nice, solid, strong cedar tree that actually you can see on the Lebanese flag. And it had a circle around it, very bold words that describe the coupling, energetics, dynamics of atmospheric regions. And so we got into this big debate. But then one of the members of the committee, I won't mention the name because just make sure not to jeopardize their funding, thought that particular logo would make us look more like part of the forestry division rather than the NSF. And so by default, this one won, and it stayed. And I was really pleased to see it continue. But I think the challenge now, as Cedar enters a new dimension, as Jeff told us this morning, is going to get into complexity. So now the challenge for Jeff, John, and the others on the steering committee is to distort this simple and elegant logo and introduce complexity in it so that it can be represented there. So good luck to you in doing that. I won't be around to do it. Second thing is to give you my recollections on the development of AMISR. As you know, every project has various phases. Well, the first phase is the three-letter phase. That started, if I remember correctly, John Kelly can correct me, I think in about 1989, there was an informal meeting at SRI to try to lay out a plan for a new radar. It was called at that time the Polar Cap Observatory. The idea was to build a high-power radar, very agile, that can point beams in various directions. And it was called the Polar Cap Observatory. The idea was to field that at the Polar Cap and add it to the other radars that were in existence, add optical instruments together with it, and really make that a major new direction. So that idea was adopted very fast. Everybody liked it, not only in our own Cedar community, but other communities that involved atmospheric sciences. And funding was not that difficult at the beginning to try to secure because it was a good idea, it was very well written, the science case was made very strongly, and things looked like they were going in a very good direction. And then the next thing is an actual location within the Polar Cap had to be chosen. And the best location in the view of the scientists involved was at Resolute Bay. And so it was called the RBO. So that was the first change in the name from PCO to RBO. And things suddenly started hitting the fan as soon as the site was selected. With my apologies to my colleagues, I'm happy actually that I'm talking after Jerry. But a very powerful man who controlled the purse strings in Washington came walking across the bridge from nowhere, and he decided that it cannot be placed at Resolute Bay. I don't remember the reasons. It had something to do with salmon, Canadian salmon or something. I never could understand it. And so the funding suddenly disappeared before it actually got in our hands. And that was a very, very difficult situation. But then Rich Benke, who was leading all of these developments, he said, no. RBO really stood for the Rich Benke Observatory. And that's the time where Rich took ownership of this radar. He was resolute about it. He was persistent. He was determined at all costs that this radar would be built. He was unwavering in his commitment to the project. And I remember having a lot of sort of personal chats with him over beer saying, geez, Rich, be careful. You're really fighting a very powerful person there. And, you keep doing the kinds of things and saying the things you are saying. You could end up in jail. And I remember him saying, we'll see who'll end up in jail. Nonetheless, I should stop here and actually ask you to pay tribute to Rich. I think he was very, very determined in what he did. And I think at a time when most of us in the community basically gave up on the project, we thought we've run into an obstacle that nobody could overcome. And he continued to be committed to it, and it's built. So it is a great deal of credit that goes to him, and a lot of acknowledgement from the community that he persevered and got us this beautiful radar. Of course, SRI came up with a very nice and elegant way to bypass the politics. And another acronym came up called the RAO, the Relocatable Atmospheric Observatory. So the idea was that you can build it, and then you can dismantle it and move it somewhere else. And that was a politically expedient way to get the project on board and get it funded and moving. But of course, it wasn't that easy to still sell it, even though it had a new dimension to the project. So we then entered phase 2, which is the 4-letter phase. And I think that lasted about 5 years. It was my misfortune to be the chair of the Cedar Steering Committee during that time. And I remember coming to the meeting and asking everybody to sign petitions. We had a petition that had 300 names to it. We sent it to all the congressional delegations. We met with the NSF upper management, trying to convince them that this is a very important project. And the steering committee spent a lot of time using words like this and many others. You can compose your others with any letter in the alphabet. And we just commiserated and worried about it, and we tried to influence things. And it took 5 years. It was quite a drought during that period of time where I had given up. Rich had not. And finally, the idea of the RAO took place. And now we're in the 5-letter phase, phase 3. And as you can tell, since 2002, when the funds became available, we built a miser and then located the first one at Poker Flat, and then riser N, that's going. And what I heard today, that the project is still moving, and there's more radars that are on the way. So it's a great success. It did take about 20 years before we got that. So for people that are starting projects from the beginning, be patient, as Bob Robinson told us today. Have a big vision, ask for large amounts of money, but be persistent and keep fighting for it. The radar is absolutely fantastic. It is the most powerful radar in the world, and the optical instruments that are with it are producing data together with the radar that are absolutely fascinating. For somebody who has seen incoherent scatter during my entire career, the results, the science results that are coming out are absolutely fascinating. And I congratulate the teams that have put this radar together and are involved in analyzing the data. The students that are getting trained, the next generation, with such a powerful instrument, I think that's going to be a mainstay for the Cedar program and many other programs for a long time. And I look back sort of 25 years worth. Now that you retire, you can spend a lot of time thinking about things like this. And I'm not taking away anything in terms of the science or the instrumentation that have been developed by the Cedar community. But basically, in my personal view, I think the development of this observatory has been the most notable and perhaps the most influential crowning aspect of the Cedar program for the past 25 years. So I think we should feel very proud that we've been part of this and been able to pull it off with the NSF support. So now let me move on to the Cedar Science success story. I had shown this slide back at the 10th anniversary, and I used the opportunity to update it. I want to tell you about this. This is the Lower Thermosphere Coupling Study. And BC doesn't stand for before Christ. That's before Cedar. And I remember a paper that was presented by Cassandra Feason, Bob Dickinson, and Ray Roble in 1986. I think it was Cassandra's PhD thesis, where they had just developed the TGCM model, and they were using that to calculate the various tidal components. And they were comparing it with as much data as they could. There wasn't very much. As a matter of fact, part of the point in the paper was to show as much data as was available in the community. And here is, for example, the Millstone Hill incoherent scatter radar, eastward winds in the Key E region between about 100 and 150 kilometers. But those data were very scant, as you can see. And that paper appealed to the community to try to get more observations and to get us all working together so they can test the model, improve it. As you can see, the model was not doing very well. And it was a very timely publication because '86 was about the time when the Cedar program was starting. And so in 1987, we held our first lower thermosphere coupling study here in Boulder. It was a small group of people, and it involved the modelers and theoreticians, and involved all the experimentalists who came in anxious to have a focus for the observations that their instruments can make. And indeed, a lot of people got attracted to the program. Some of them are here. Cassandra is one. Maura is another one. Roberta, I don't think she's here. Larissa was involved. Barbara was involved. But you can tell there's something in common with all of these names. They all end up with an A. And I never could figure that out. Of course, there was an exception. Jeff Forbes, who led the project, his name didn't end up with an A, but he led us through this campaign, planning, taking the data, and gathering the observations. So what happened after 25 years? Well, it's very, very exciting. I'd like to share that with you. This is what we have now. TGCM became TIGCM, then became TIEGCM, and I think there's a model called Wacom. I'm not sure about the spelling. And of course, there's GSWM that Maura provided. And we got a lot of data. Everybody is happy. So there's good agreement between the models, the observations, and it's probably time to put that project to bed. There's a few lessons, though, to learn from this. I think the project now has moved from what they call climatology to try to understand variability, and of course complexity, which is inherent in the data. So I think it bodes well for the future. So with this, I hope I entertained you enough. I'd like again to thank you for inviting me. I'd like to wish the Cedar community a very happy 25th anniversary. Keep going for the gold, and make sure you don't forget the old-timers like Jerry and me, and invite us for the 50th anniversary. Thank you very much.